Okay, today I'm going to show a synthesis for turning cyclohexane into an aromatic ring. First, we know how to add a double bond if there's a bromine attached. So I'll start by going back to that. Luckily, we also know how to add a bromine to the allylic carbon atom. So I can go back to this. We then know how to add a double bond, like in the last step, as long as there's a bromine. So, again, I will go back to this. Then, again, we know how to add a bromine to the allylic carbon atom. So I can go back to this. And finally, we know how to add that bromine. And we know how to add that double bond as long as we have a bromine. Then we can go back to the original starting material from there. So in the forward direction, we add this bromine by adding Br2 and light, and which will add a bromine through a radical mechanism. In the second, we will create this double bond using a strong sterically hindered base such as tert butoxide or sodium tert butoxide and its conjugate acid, which will add a double bond through an E2 mechanism because of the steric hindrance and the strong basicity. We then know how to add a bromine to the allylic carbon atom using NBS, which proceeds through a radical mechanism, light, and pyridine. We then know how to remove that bromine and create a double bond in the same way we did in step 2 with the sterically hindered base. Then we can add another bromine to the allylic carbon atom in the same way we did in step 3 with NBS, light, and pyridine. And finally, we can remove that bromine and create a third double bond with a sterically hindered strong base through an E2 mechanism. In all these steps where we create a new double bond, it will add to the carbon that is not already part of a previous double bond, because the p orbital that is in the plane of the coming out of this plane, coming out of the board, has already been used, and if it was to add to this carbon, it would be too sterically hindered. Yeah, so to sum it up, the first step we have Br2 and light. Second step, we have a sterically hindered base, in this case sodium tert butoxide, and its conjugate acid as a solvent. In the third step, we have NBS, light, and pyridine. In the fourth step, we have another sterically hindered base. I am using sodium tert butoxide again, and its conjugate acid as a solvent. In the fifth step, we use NBS again with light and pyridine. And then in step 6, we again use a sterically hindered base, which I am again using sodium tert butoxide for. Thank you.